In this video, I'll be sharing a mini inverter design that uses 8 MOSFETs. What makes this design special is that it doesn't require a microcontroller like many of my previous inverter projects. Instead, I use operational amplifiers to handle the protection functions. This makes the project much easier to build and replicate compared to my earlier designs. So let's get started. Before we get started, I'd like to thank JLCPCB for sponsoring this video. JLCPCB is one of the pioneers in the PCB manufacturing industry, and I'm truly grateful for their support. Many of the projects you see on this channel would not have been possible without their help behind the scenes. Right now, JLCPCB is offering a special promotion for new customers, including discount coupons worth hundreds of dollars. If you're interested, be sure to sign up using the link in the video description below and claim your welcome rewards today. About 2 weeks later, my PCBs arrive. To save on shipping costs, I usually combine several projects into a single order whenever possible. As always, the PCB quality is excellent. Since all the component values are clearly labeled on the PCB, I'll just briefly go through the assembly process. Instead, I'll focus on explaining a few parts that I think might be a bit confusing. Here, I have 3 MOSFETs connected right at the input stage. Their job is to protect the circuit in case the input battery is connected with reverse polarity. The downside is that they will dissipate a few watts of power during operation. If you prefer, you can simply bypass them with a short connection. Next comes the installation of the power MOSFETs. I'm using 8 MOSFETs in this project. I recommend choosing MOSFETs with a current rating of at least 108, such as the IRF3205 or an equivalent device. MOSFETs with higher current ratings usually have a lower RDS on, which means lower conduction losses and cooler operation. One more thing to keep in mind. You only need to use insulating pads for 4 of the MOSFETs. The other 4 MOSFETs can be mounted directly to the heatsink. That's because in this design, the 2 transformer leads will be connected directly to the aluminum heatsink. This transformer was salvaged from an old UPS. It's rated at 1000 watts with a 24-volt input. That's a little smaller than the power rating of this inverter, but it's good enough for testing. A small toroidal core placed around the primary winding helps reduce the inverter's no-load current consumption. This inverter can be used with a wide range of loads, such as light bulbs, TVs, power saws, or water pumps. As long as the load power stays within the transformer's rating, it should work without any issues. With a 24-volt system, the maximum output power can reach around 2000 watts. However, I recommend keeping the load below 1500 watts for the best reliability and long-term stability.